So we're going to go ahead and look at solving two-step equations today. We've already looked at solving one-step equations, so we're just adding a little bit more detail to the equations that we're solving. So again, to review, we are solving today, we're finding the value of, or the solution to our unknown variable. Once we start in our next lesson looking at multi-step equations, we're going to be simplifying first before we solve. But our instructions are going to be to solve the equation. Simplifying is just part of how we would get to that solution. And we're not working on this in this particular lesson, but oftentimes you'll hear that word evaluate. Evaluates when we're finding a numeric value for something. Oftentimes we're substituting in a number for a variable in an expression to find an actual numeric answer to that problem. Okay, just like with one-step equations, we're taking order of operations and we are going in using the inverse of the order of operations. And so we are starting, instead of simplifying where we start at the top of order of operations and we work our way down, since we are solving, we start at the bottom of order of operations and we work our way up to the top in terms of what we are choosing to eliminate first. Okay, so we're going to go ahead again and we're solving these problems and we are using what we call inverse operations. So we want to start again at the bottom of order of operations. So that's adding, subtracting. That's what we're going to eliminate first. So the inverse, or the opposite of negative or minus 10, is going to be add 10 to both sides. So I'm left with 5x equals 20 plus 10 gets me 30. Divide both sides by 5 because these are being multiplied. Remember, a coefficient is being multiplied by the variable, so the inverse of multiplying is to divide. 30 divided by 5, I get 6. So that is the solution to my problem. X is equal to 6. Okay, let's try another one. Again, we're starting at the bottom of order of operations. So lowest on order of operations is adding, subtracting. That's what we're going to eliminate first. Opposite of adding 9 is going to be subtracting 9 from both sides. So then I'm left with 1/3 x. 21 minus 9 gets me 12. Now, we talked about this in one-step equations. Well, first is 1/3 is a coefficient. It's being multiplied by x. So the inverse operation is going to be to divide by 1/3. But again, what we looked at in one-step equations is that when we divide by a fraction, we are multiplying by what we call the reciprocal. So the reciprocal, we take our fraction and we flip it, the numerator and denominator switch places. So these 3's are going to cancel, these 1's are going to cancel, and we're left with x. Multiply by 3 over 1, which is the same as just 3. 12 times 3, I get 36. And so that's how we do two-step equations. Okay, lastly, we're going to continue on with what we consider two-step equations, meaning we're doing like one adding, subtracting, one multiplying, dividing. But now we're going to be looking at fractions. Okay, now, very few students I've encountered. In fact, there's only one student that I've ever worked with that was like, oh, I really like fractions. I'd rather work in fractions than decimals. One student out of the hundreds and hundreds that I've worked with. So let's get rid of our fractions. When we do what we call clearing fractions, is we first look at our denominators. What is the least common denominator? What number can I multiply 3, 4, and 12 into? Well, what we call the least common denominator, let's make our pen here, is going to be 12. So we call it the least common multiple, or least common denominator in this case is 12. So what we're going to do is we're going to actually make ourselves this really large distributive property. And we're going to multiply every single term by 12. Now what's going to happen is, since we're multiplying a whole number by a fraction, we are going to multiply by the numerator, or the top number, divide by the denominator. So 12 times 1 is 12. Divide by 3. So 12 divided by 3. So I get 4y. Carry down my addition sign. 12 times 1 is 12. Divide by 4 is 3. carry down my equal sign. 12 times 5 is 60. Divide back by 12. I'm left with 5. Now this looks like a nice simple two-step equation. All I did to get there was I found my least common denominator and I distributed it to all of my terms and we simplified. Now I can solve. We want to start with adding, subtracting. I'll have it adding 3, so the inverse of that is going to be subtracting 3. So I get that 4y, 5 minus 3 is 2. Be careful here, these are being multiplied, so the inverse is to divide. My answer is not 2. The smaller number is on top, which means I'm left with a fraction. Yes, that is okay. In fact, most real-life answers, real-life problems you're going to solve are probably not going to end up with nice whole numbers. Now, the last thing that I need to do anytime we end up with a fraction answer is I need to simplify or reduce. These are both divisible by 2. So I get y equals 2 divided by 2 is 1. 4 divided by 2 is 2. So y is equal to 1/2. Okay, moving on, we have two I guess real life type examples. We're going to set up the problem after this, but let's finish with this last clearing fractions problem between 7 and 14. My least common multiple or least common denominator is going to be 14. So I'm going to multiply everything times 14. I'm going to distribute. 14 times 2 is 28 divided by 2. 14 times 2 is 28 divided by 7. So I get 4m minus 14 times 1 is 14 divided by 7 is 2 equals 14 times 3 is 42. Divide by 14, and I'm left with 3. Again, found the least common multiple between these numbers, the denominators. Took that number and distributed it to all 3 terms, and now I'm left with a simple two-step equation. Start at the bottom of order of operations, it's adding, subtracting. Inverse of subtracting is adding. Add 2 to both sides. 4m equals 5. Divide everything by 4. M equals 5/4. Now, that can't be reduced. I'm absolutely fine with you leaving them improper. If I was asking you, for example, like the next problem, which we're looking at actual units, so meters, feet, that kind of thing. I can't say, hey guys, I ran 5/4 of a mile today. That doesn't really make sense. So if I'm asking you in a word type problem or something where I have units, you do need to make sure you convert it to a mixed number. But in terms of just solving, leaving them improper is fine. If you want to make it a mixed number, so your other option would be m equals 1 1/4. There we go. Okay, last 2 examples here. We have application type problems. So first we're going to write the equation, then we're going to solve. Okay, so an emu that measures 60 inches in height is 70 inches less than 5 times the height of the parrot. What is the height of the parrot in inches? So if I get a fraction, an improper fraction, I am going to have to make it a mixed number here. So first thing we want to do, I'm going to declare a variable, p. That's what I'm looking for. That's going to be the height of the parrot. You can use whatever variable you want. If you just want to use x every time, that's totally fine. First thing you always want to do is declare a variable. Worst thing's going to be you set up this awesome equation, you solve it, you get an answer, and you're like, I don't even know what that meant. Write down what your variable means. Now let's write an equation. An emu is 60 inches tall. That is 70 inches less than. So we're going to have minus 70. When we see that word than, it means something minus 70. 5 times is just multiplying the height of the parrot. There's my two-step equation. Now let's solve it. Get rid of our add, subtract first. Inverse of subtraction. Let's add. So add 70 to both sides. 70 plus 60, I get 130 equals 5p. Coefficients are being multiplied by the variable. The inverse of multiplying is to divide both sides by 5. So 130 divided by 5. We get 26 equals p. Well, this is a word problem. Just writing p equals 26 or 26 equals p is not going to work. We need to write a sentence answer. The height of the parrot is 26. It says how many in inches, so inches. And the height, so tall. Okay, that makes sense. These aren't to scale here, this picture, but a parrot is definitely smaller than an emu. The emu is 60 inches. The parrot is a lot smaller than that, so that makes sense. If we solve this and we got something larger than 60, that would not make sense because parrots are definitely smaller than an emu. Okay, last example for today, an ostrich. Okay, so we have our ostrich and our kiwi. An ostrich is 108 inches tall and is 20 inches taller than 4 times the height of the kiwi. So we want to know what the height of the kiwi is. So K equals height of the kiwi. So declare our variables, write down what it means. Okay, the ostrich, which is 108 inches tall, is 20 inches taller than, so plus 20, 4 times the height of the kiwi. And now let's go ahead and solve. Adding 20, so we're going to subtract 20. 108 minus 20. We get 88 equals 4k. Again, these are being multiplied, so the inverse is to divide. And so we get 22 equals k. Again, it makes sense. Kiwis are definitely smaller than an ostrich, and not to scale here, but kiwis are definitely smaller, so it makes sense that we got a number smaller than the height of an ostrich. But now we need to go ahead and write it in a sentence. The kiwi is 22 inches tall. And there we go. If you have any questions solving or setting up two-step equations, please let me know.